In this video, we'll look at sections 5.2 and 5.3. So 5.2 is on representing unit fractions. So we talked about the unit in the last video. So a unit fraction is basically a fraction with a numerator of 1. And we want them to have a firm understanding of unit fractions because we're going to be using them as things to count with. For example, when we add or subtract fractions. So later on when we have 2/3 plus 1/3, we can think of this as 2 copies of 1/3 plus 1 copy of 1/3, which would give us 3 copies of 1/3. So thinking of the unit fraction as our unit, just like you could have 2 copies of a cookie plus 1 copy of a cookie is 3 copies of a cookie. So we're treating this unit fraction as our unit of measure. Okay, so here we have some examples: 1/2, 1/4, -1/5, and we're using the idea of cutting. Okay, so we cut into the number of pieces in the denominator, and then we count the numerator, which in all cases will be 1 either in the positive or negative direction. Things to remember, and you can talk to students about this. If you have 0 to 1, if you're cutting it into halves, you make 1 cut. Oh, sorry, forgot I can't write on this. So to cut into half, you make 1 cut, and it makes 2 pieces. For quarters, you would make 3 cuts in total. So these are your cuts, but I try to bring to their attention that there's 1, 2, 3, 4 equal segments in this unit, okay? Because that's a little bit counterintuitive to them. So they want to make as many cuts as there are in the numerator. And again, this idea of the numerator being the number of copies and the denominator being the number of cuts, or you could think of it as numerator as multiplication, denominator as division. So this, we start with a continuous model, the number line. Here we have a area model. So these are always interesting because here notice we have various units, and in this case we have 2 circles as the unit. Okay, so this is both discrete and continuous because you have 2 discrete objects, okay, but within the single object it's continuous. If you found the area, you would shade in everything. Okay, so that sometimes makes things weird for students. They wonder if they can cross over into the other circle. So for example, if we had these 2 circles and you wanted 3/4, okay, cutting them, each of the circles in half, if we're thinking of this as a unit, now there's 4 1/4, even though with respect to the single circle it's a half. And if we want to shade 3 of them, sometimes they don't quite understand if they can cross into a new circle because it doesn't have this continuity that we have with the number line. It has it in one circle, but not when you cross over to another. So these can sometimes bring up interesting conversations. And then we also have a discrete example. Okay? So we're thinking of all of these triangles are the unit. So that's interesting because there's 12 triangles, but we're saying the 12 triangles are 1. Okay. And how do we represent 1/4 of the triangles? And you can look at different ideas. They can count 1 out of every 4. So 1 out of this 4, 1 out of this 4, 1 out of this 4. Okay. Or you could have them circle groups of 4. You can have them count by 4s, 1, 2, 3, 4, 1, 2, 3, 4, or just, you know, ask them to find it and see what they come up with, and then you can share the ideas with the class of different ways of looking at it. And now composite fractions. So composite meaning, I'm going to say making up more than one piece, although I don't know if that's the definition. Google it. Okay. So composite fractions is we're using the idea of cutting and copying again, where the denominator is cutting and the numerator is the number of copies. Okay? And this is going to be especially useful, especially for fractions where the numerator is greater than denominator, or the improper fractions. So just looking at 5/2, okay, if they only have a part-whole conception of fractions, 5/2 makes absolutely no sense. You can't have more than 2 halves. So what would 5/2 be? But if we think of it as 5 copies of the unit fraction 1/2, they can think of, in this case, there's a number line. And they could think here's 1 copy, there's 2 copies, 3 copies, 4 copies, 5 copies. And notice they're accumulating the number of copies as we go. So 5 copies of the 1/2. Okay? So this understanding, again, it's going to help them with addition and subtraction, and it's also going to connect to multiplication and division, which we'll see in the next unit. So notice here we have proper fractions, improper fractions. We look at both positives and negatives. Surprisingly, with fractions that simplify to whole numbers, you think they'd see that right away, but they don't, and it's good for them to continually connect this idea in both directions, that 12/6 is equivalent to 2. Okay, but given 12/6, know that that's 2, or given 2, know that that's 12/6. And there's some more problems. So the first one, we had number lines, and again, this idea of multiple representation, so the number lines are continuous. Here we have area models, and again, notice that we always define what the unit is in every case, and in this case, a single rectangle is the unit. So they may need this one if it's greater than 1, and they might not. Okay. So here, they could cut this into 4 equal pieces, and you take 1, 2, 3 copies of 1/4. And we're going to have them use this language, and you should try to use this language as well, because it makes them connect that idea of the unit fraction as the unit that we're making these copies of, the number of something, so they could start using their counting ideas with the fractions. So after the area model, then we also have some discrete models with the triangles again. So one thing that's nice to do with the triangles is have them start by making a drawing of the unit fraction. So I think there's 12 here, so the unit fraction, this would be 5 copies of 1/6. So the unit fraction is 1/6. What does 1/6 look like? Well, that would be 2 triangles, 1 out of every 6. Okay, and so then that would be 2 triangles. Then you take 5 copies of that. Well, 10 triangles would be 5/6 of the triangles. And I think that's all we have for those. In the next video, we'll look at 5.4.